here's the response. It finally does get around to saying that, yes, I'm here, and this is my MAC address that pairs with that IP address. When you're talking about a single network, the routing of packets actually drops to a layer 2 or a switched environment. If you're talking about that bridge between two different networks, that's when a router comes in. It routes traffic between networks. And for that, you only use IP address. While you're on a switched network, you use MAC addresses. Now, for some reason, this trackpad keeps double-clicking on it. So a TCP connection has what's called a three-way handshake. It's part of this overhead to make sure that the source can reach the destination, and the destination is what we're talking. So they can ensure that the data reaches the destination and that the source knows that it's reached the destination. That handshake starts off with what's called a SYN packet or a sync packet. This is the source sending to the destination saying, I want to make a connection with you on a particular port using TCP. The destination will then reply with an ACK packet or an acknowledgement packet and say, yes, I've received. It's actually got two flags set, a SYN ACK. I've received your sync and I am acknowledging it. And the last packet in the handshake is from the source to the destination, again saying I acknowledge that action and I'm ready to send data. Then towards the end, it really should have a couple of ACKs and a fin packet or a finished packet. But in this case, I was using Nmap as a port scanner, and Nmap is a little bit rude and sends a single packet to terminate the connection called a reset packet. This is actually one of the ways that you can put countermeasures into your network as well, because that reset packet doesn't necessarily actually have to come from the source or destination. You can build a IP address packet, set that reset flag, and send it to both the source and destination. And as long as one of them receives it, that connection falls apart. It's that pull on that thread and everything unravels. And you can do a lot more with Wireshark, but that have to be for another presentation. All right. To another tool, traceroute. So if you want to know, this is primarily for networks that are attached to other networks, and that you're sending a connection from one network to another, and it may pass through more than one network before it reaches its destination. And so you have routers involved in this path. Traceroute takes advantage of a part of a header. Both ICMP has these. Pretty much all of the IP frames have these. And that's the time to live field. This is just a integer that starts off fairly big, depending on your operating system. It can be anywhere from The smallest I've seen was 25, all the way up to 255. Okay. 56 is pretty common. Every time that packet reaches a router, that router interface decrements that time to live field. So if it was 56, it's now 55. It reads the packet, finds out where it needs to send it next, and sends it on its way. And when it reaches the next router, that same process happens. If the TTL reaches 0 after it's decremented, so a router has received that packet, minus 1 from the TTL. If that value is 0, that packet is dead. It's time to live is gone. So it drops it on the floor. But if it is configured according to RFC, essentially the published rules of the game, as it were, it is to send a ICMP packet back to the source, letting the source know that that packet that it just sent will never reach its destination because its TTL has been exceeded. That fact can be used to determine the IP address of routers between the source and destination, hence tracing the route. Because that router is going to initiate that return packet, it's going to have its IP address for that interface as part of that packet. So the source can tell it where it stopped. Well, if you use a traceroute client, what it does is that it first sets a TTL value of 1. And so the first router that packet hits will decrease the TTL. It reaches 0. If the router is properly configured, it will send back a reply. The client then receives that and builds that path that adds that IP address to it. Sends the packet again with a TTL of 2, et cetera, et cetera. And so you get the IP address of each router in the path. There are 3 main tools that you'll come across for Windows. It's still called traceroute, but it's spelled without vowels for the route part. For Linux and Mac OS, just spell the whole thing, traceroute. And then there's a little bit of a fancier one. Excuse me, talking too much. That has a whole bunch of other features that, if you really get into networking, become very useful. And that's MTR. It does have a built-in GUI interface. So if you like the display for that, this is a really good tool. But its command line, it can also be configured very well to feed into other tools. So if you like to write your bash or shell scripts and you want to take in that path and do something with it, the formatting for this particular tool is particularly interesting. So before we get into InMap, what's anybody using something other than traceroute, either on Windows or on Linux? Everybody's just a fan of plain old traceroute. Well, great. If you
-I, capital I.
well, okay. John, would you like to tell the group?
That uses ICMP to talk to all the routers that are in the path. And you typically get more of a response because routers are often open in their firewall to respond to ICMP pings. And so when diagnosing an end-to-end path connection, I find it way more useful to use the -I option compared to the UDP-based traditional trace route. That said, you have to have sudo privileges typically on a Linux box to use that ICP-based query.
I alluded to it earlier, but because traceroute is both a useful network troubleshooting tool, but also a useful reconnaissance tool for an attacker. Some folks have started not configuring routers to send back TTL exceeded packets. And so you may get trace routes that have big holes in them. Some are even configured so that even if additional routers beyond the one that says, no, I'm not sending anything, sends a packet back, it drops off. And so you can get kind of black holes where you say, I can't reach Google. Why can't I reach Google? Or I can't reach PayPal or whatever site you want to. I'm going to trace route it. You'll like go up to your ISP and across a section of the backbone, and then suddenly everything stops. And it'll just go through whatever the default number of packets is and stop. That's probably why. Is one of the routers is configured to stop traceroute from working, essentially. So, Nmap. How many people have used Nmap before? All right. Well, again, I'm not going to tell you anything new here. Nmap stands for Network Mapper. It's been around for ever and a day, constantly evolving and improving. It is nearly to the level now that you can rely on it for some network vulnerability scanning, in fact, using the network scripting engine. But what I wanted to highlight here was more just about port scanning. And that's also a really good way of discovering hosts that are on your network, devices that are on your network. So breaking down this Nmap command here, we have